Good morning, grade 10s. I hope you guys are having a good day so far. Today we are going to be talking about slope and start our unit on it. So before we even get started, I want you to talk with your partners about this little graph we have here. And I want you to talk about this. How would you describe the steepness of each of these lines? And can you put a number to the steepness? Which is the most steep, which is the least steep, and what are the numbers for those lines? So yeah, take a minute and talk to the person around you, and we'll come back in a couple minutes, so you can pause the video. Okay, so I hope you had a chance to talk that over, and we're going to start with the first question is, how can we put a number to each of the steepness? And I would suggest that we can actually count how many boxes it goes up and how many boxes it goes over. So let's take the line FP, for example, this line right here. And we can see that it goes down one line, and then it goes over 1, 2, 3, 4. So that's a pretty not steep line. So let's look at the lines, and let's look for the most steep. And I would say that line would be B and C. So let's count how many it goes up. That would go 1, 2, 3, 4, up, and 1, 2, over. And so that one would be the steep. And if we wanted to count the other ones, we could count them as well. And we will find that it is the line BC is the steepest, and line FE is the least steep. But before we keep going, I want you to consider what happens at line BA, down at the bottom. Does it have, how do we describe that steepness? So take a second and think about it, and actually it has 0 steepness. It's just a horizontal line, so it just goes over a bunch, it doesn't go up any. So it's just 0 steepness. And we'll talk a little bit more about that. So then, going on to example 1 in your note package, now we have this line segment, and we're going to be more explicit with how we count things. We have this, there's an idea called slope, and slope equals rise over run. And what do we mean by rise over run? Exactly what we did in the last problem, where we counted how many it goes up. 1, 2, 3, 4, 5, 6. And then we can count how many it goes over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we can make that fraction, so our slope is rise over run, so it went up 1, 2, 3, 4, 5, 6. And our run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Giving us our slope. Perfect. So we can move on to our next example, and again, we can find a couple nice points, one at the end, one at the beginning, and then we can count how many. We usually start this left to right, and we got to figure out where this line is going. So we can count how our slope is rise over run. So this one will go 1, 2, 3, 4, 6, 7, 8, 9, 10, 10 down. So our rise would be a minus 10 because we're going down 10. And this would be over 1, 2, 3, 4, 5. So our slope equals minus 10 over 5, which is the same as saying minus 2. Sweet. Yeah, so if you kind of notice, this one already had a positive slope, which went up to the right, and this one had a negative slope. And that's what we're going to talk about next, is that we actually have 4 kinds of slope. We have negative slope, which is going down to the right, kind of like a downhill for this biker. And then we have a positive slope, which is going up and to the right. So it'd be hard for the biker to get up. And then we have horizontal, which is 0 slope. And then we have vertical, which is undefined. And that's undefined because if we did a rise, it would be a bunch, and our run would be 0. So that would be something, let's say 1 over 0, and that's why it's undefined, as we can't have the slope. Okay, so our next example, it wants us to draw a line segment with each given slope. So our slope is 7 over 5. So let's first remember that our slope equals rise over run. So that is the same as saying 7 over 5. So our rise is 7 up and our run is 5 over. So I'm just going to pick any point. You can pick a point. I'm going to pick right there. And I'm going to go up 7, 1, 2, 1, 2, 3, 4, 5, 6, 7. I'm going to go over 5, 1, 2, 4, 5. So our point is right there. And then we can just draw a line through those guys. Use a ruler. I'm on a smartboard, so that's not very perfect, but do your best. And that would give us a line with the slope of 7 over 5. Next example, the same thing, is that our slope is going to be minus 3 over 8. So then now, where our slope is going to be a minus 3, so our rise is minus 3 over 8. I'm just going to write a rise over run so we remember. So our run is minus 3, so it's going to go down 3 and over 8 to the right. So I'm going to pick another point. I'm going to pick one up here this time. I'm going to go down 3, 1, 2, 3, and over 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. A little bit off the graph, but that'll be right there. And then we can connect our lines, use a ruler, draw a nice straight line, and there we go. We've graphed our line with the slope of minus 3 and 8. And if you notice again, it had a negative slope, so it's going down to the right. And our first one had a positive slope, and that's going up, up, and up to the right. Yes, so you can pause the video and make sure everyone's caught up. Okay, so moving on to example 3. It says, determine the slope of a line that passes through point C, which is at 5 and negative 3, and D, which is at 2 and 1. So the first thing we're going to do is we're going to plot our points on our graph. So I'm just going to assume that each of these is 1, so it's just going to be there. Negative 1, negative 2, 1, 2. And then we can plot our points. So yeah, now that we have our graph drawn, we can go through and label our points. So it'll be C at minus 5 on our x-axis, and then down 3, which would be here. And then we go up to our other point, which is at 2 in our x spot, and 1, which would be here. And then we can connect our line through there. Nice, so we got a line that now we can find the slope of. And remember, our slope is rise over run. So we can count how far does it take us to go from point C, so I'll label that point C, and point D. How far up and how far over do we have to go? So we're just going to count 1, 2, 3, 4 up. So it'll be 4 over 1, 2, 3, 4, 5, 6, 7. 7. So our slope is 4 over 7. Now, do you think we actually had to draw the line for this one? Or could we have just done it using our points? And that's what we're going to talk about next. So you can pause the video to make sure everyone gets the graph down, and then we'll keep on going. Okay, so now we're talking about the same example we just did, and that we didn't actually need to draw the line in for this one. And we're going to learn why. So there's another way we can find the slope of a line, and this line passes through A, and I'm going to put a bracket, x1, comma, y1, and B, bracket, x2, comma, y2. And the way I do that, the reason I do that is to make sure we know which point our x and y values are coming from, because the slope of a line AB can be found by going y2 minus y1 over x2 minus x1. Yeah, so you can pause the video to make sure we get it all caught up, and we can move on to some examples. Okay, and on to our final example. So example 4 says, Yvonne recorded the distance she had traveled at certain times since she began her cycling trip along the Trans-Canada Trail in Manitoba, from North Winnipeg to Grand Beach. She plotted this data on the grid, and we have that shown there. So the question is, what is the slope of the line through the points? So we can just take 2 of our points. I'm just going to pick the 2 in the middle, and let's find the slope in between there. So I'm going to label this guy. Let's find what the x is. X at the top point is 2, and our y value at that point is 48. So that's our x1 and x2. x1 and y1. Sorry for that. And then for our bottom point, we have our x2 will be 1, and our y2 will be 24. Okay, so we can plug in, we're going to use our formula this time, and if we remember it from the last example, it is our slope equals y2 minus y1 over x2 minus x1. So then we can just plug in our values. So then our y2, and I said y2 was going to be our bottom guy. So I'll label him. This is I'm just going to call him point 2 and point 1, just so that we're really clear. And so I'm going to put my y value, which is 24, minus y1, which would be 48, over our x2 would be 1, minus our x1, which is 2. And then so if we work that out, we get 24 minus 48 will be minus 24, divided by 1 minus 2 would be minus 1, which is the same thing as saying 24, because minus 24 divided by a negative 1, our negatives will cancel, and we'll get 24. Nice. So what does the slope represent in this one? Our slope represents the kilometers, so it's rise over run. So that would be our kilometers on our y-axis would be kilometers over hours, or kilometers per hour. So it's talking about a speed. The slope is our speed. And then how can the answer to part B be used to determine how far Yvonne traveled in 1.1 3/4 hours? It's actually, because we know that it's a speed, we can figure out how far she traveled. And so we found our slope was 24 kilometers per hour, so I could have wrote 24 kilometers per hour. And we're going to multiply that by how many hours she has. So that'll be 24 times 1 3/4. And I'm just going to get rid of the mixed fraction. So I'm going to go 24 times, that's the same as saying 7 over 4. And then we can multiply this across, and that will give us 24 times 7, or 1. You could also just convert this to a decimal, but that would be 1.75. That would be a little bit easier. So I'm going to switch this way so we don't get confused with all our fractions. I'm just going to convert this 24 times 1.75, and that should give us 42 kilometers. So if we wanted to explain our answer, okay, so if she travels 24 kilometers per hour, then she would travel 42 kilometers in 1 3/4 hours. And you can pause it there just to make sure everyone gets that written down. And we're going to end this part of the class with an assignment, so you can go through these questions listed on the board. And yeah, that'll be the end of this part.